Alright, welcome to today's class. In today's class, we will be dealing on rectilinear motion as part of the application of differentiation. What then is rectilinear motion? Rectilinear motion refers to the movement of an object along a linear path. It refers to the movement of an object along a linear path. Given that distance or displacement is a function of time, that is to say, s is a function of time, s of t, where s is distance or displacement. Measured in meters. And then t is time, measured in seconds. Now recall that velocity v or speed is the rate of change of distance or displacement. Velocity v or speed is the rate of change of distance or displacement. That is, v of t is equal to d all over dt multiplied by s. That is, v of t is equal to ds all over dt. Now note this, d all over dt is known as rate of change. So whenever we say rate of change of something, we mean d all over dt of that thing. Now let's consider acceleration. Acceleration a is the rate of change of velocity. That means a of t is equal to rate of change of velocity. That is, a of t is equal to dv all over dt. Now write down these rules. If you are given displacement and you are asked to find velocity or speed, simply differentiate once. If you are given displacement and you are asked to find velocity or speed, simply differentiate once. And then the second rule is this: if you are given displacement and you are asked to find acceleration, simply differentiate twice. If you are also given displacement and you are asked to find acceleration, simply differentiate twice. Then thirdly, if you are given velocity and you are asked to find acceleration, simply differentiate once. Now let's take an example. All right, so let's solve this example. An object has its position defined by s of t equals t raised to power 3 minus 9t raised to power 2 plus 24t plus 20. A. What is the velocity function? B. Find the acceleration at which the body moves. And then C. Find the displacement and total distance traveled by the object at t equals 1.5 seconds and t equals 7 seconds. Our first task here is to write down the given parameters. So we have s of t equals t raised to power 3 minus 9t raised to power 2 plus 24t then plus 20, where s is known as distance traveled or displacement. Now, in solving this problem, you have to consider the 3 rules I stated earlier. The first rule is if you are given distance or displacement and you are asked to find velocity, simply differentiate once. So since we are given distance s and we are asked to find velocity v, so we are going to differentiate once. So we have the s all over dt. So v equals d all over dt multiplied by s. So let's substitute into the equation. So we have here v equals d all over dt. Now s is given in the question and s equals t raised to power 3 minus 9t raised to power 2 plus 24t and then plus 20. So v is equal to, if you differentiate t raised to power 3, it would give you 3t raised to power 2. According to the general method of differentiation, you multiply t by its power and then subtract 1 from its power. And then minus, if you differentiate 9t raised to power 2, it would give you 18t. You multiply 9t by its power, which is 2 multiplied by 9, gives you 18, and then you attach t, and then subtract 1 from 2, and plus 24. If you differentiate 24t, it will give you 24. And also, if you differentiate 20, it would give you 0 because 20 is a constant. So our velocity here is 3t raised to power 2, 18t plus 24. Let's answer the second question. We are asked to find the acceleration at which the body moves. And recall the second rule. If you are given distance or displacement and you are asked to find acceleration, simply differentiate twice. Or if you've gotten velocity, simply differentiate velocity. So acceleration, which is a of t, is equal to dv all over dt. Remember, acceleration is equal to rate of change of velocity. Now let's substitute into the equation. We have a of t equals d all over dt multiplied by, substituting v into this equation, we have 3t raised to power 2 minus 18t plus 24, and then close bracket. So a of t is equal to, if you differentiate 3t raised to power 2, it would give you 6t. 2 multiplied by 3 is 6, and then you attach t. 2 minus 1 is 1, so we are left with 6t. If you differentiate 18t, it would give you 18, so we have here negative 18. And also, if you differentiate 24, it would give you 0, because 24 is a constant. So our acceleration is equal to 6t minus 18. So C says, find the displacement and total distance traveled by the object at t equals to 1.5 seconds and t equal to 7 seconds. So the displacement at t equal to 1.5 seconds. And in the question, displacement S is given as t raised to the power 3 minus 9t raised to the power 2 plus 24t plus 20. Now we have been given the value of t, which is 1.5 seconds. Our major task here is to substitute the value of t into this equation. So substituting, we have 1.5 raised to power 3 minus 9 multiplied by 1.5 raised to power 2 plus 24 multiplied by 1.5 and then plus 20. So we have here 1.5 raised to power 3 gives us 3.375. That is 1.5 multiplied by 1.5 multiplied by 1.5. And then minus 1.5 raised to power 2 multiplied by 9 gives us 20.25. And then plus 24 multiplied by 1.5 gives us 36 plus 20. So if we sum this up, we would have S of t equals 39 plus 0.125 meters. So this is our distance or displacement at t equal to 1.5. The next one is at t equal to 7 seconds. S of t equals t raised to the power 3 minus 9t raised to the power 2 plus 24t plus 20. So if we put t as 7 seconds into the equation, we would have S of t equals 7 raised to the power 3 minus 9 multiplied by 7 raised to the power 2 plus 24 into 7 multiplied by 7, sorry, plus 20. So we have 7 raised to the power 3 is equal to 343, and then minus 7 raised to the power 2 multiplied by 9 gives us 441, and then plus 24 multiplied by 7 is equal to 168, and then plus 20. So finally, s of t, which is the distance, is equal to 90 meters. So this is our final answer.